Hello again, this is Ms. Nakayama. Today's lesson is 4.6, Graphs of Other Trigonometric Functions. Voice is getting a little bit better, so hopefully it will continue. Our objectives today are to talk about the functions we didn't talk last time, which were sine and cosine. So we're going to cover tangent, cotangent, cosecant, and secant. And y'all, before I go on, I want you to know how much easier it is doing this in MyLab Math versus by hand. It is all about knowing the characteristics of the functions and being able to pick out the right graph. So that is my objective in this video. All right, so first we're going to talk about the tangent function. It has a period of pi. It is an odd function, which means the tangent of negative x equals the negative tangent of x. That negative sign moves out front for an odd function. It is undefined at odd multiples of x equals pi over 2. That is always half the period. So even though you need to be able to pick out the graphs, sometimes your questions will be just about those asymptotes. So I have to talk about how to find them. Okay. Looking at this graph right here, this is the graph of one period. There are 5 key features to it. It begins and ends with the vertical asymptote. Halfway between, it crosses the x-axis, which is our midline, but crosses the x-axis. Halfway to the right, it goes up, and halfway to the left, it goes down. So one of the key features to summarize this is this graph rises as you go from left to right. And you're going to hear me talk about that when we go through and pick out the right graph. So here it is summarized again. I do need you to know that where it's undefined, remember that's where we're going to have vertical asymptotes. So here is a picture of it with multiple periods on the same graph. All right, same kind of thing, just giving you more of what I just talked about. So pause if you want to read it more carefully. Choose the correct graph of 2 periods of y equals 6 tangent of x over 6 below. So we have 2 graphs. And as I said, the key feature is that it's a tangent function, and the tangent function rises. So when I'm looking at these graphs, A rises, B rises, but C does not. So there's no way for C to be our graph because it's falling. Okay. Next, I'm going to look at the period of my function, and the period is pi over the coefficient of x, which is 1/6, and that becomes 6 pi. So my asymptotes are at plus or minus 1/2 of the period, and that becomes plus or minus 3 pi. So I can look, and A does not have an asymptote at 3 pi, so that means that B is my answer. And if you needed to know, the vertical stretch of 6, that right there gives you the 6 in front, tells you that halfway between my asymptotes, halfway between a 0 and an asymptote, it has to go up to the A value when it rises. Okay, look at this next example. Choose the correct graph of 2 periods of y equals the tangent of x plus pi over 10. Again, first thing I'm going to do is notice that it's tangent, and that rises. So A rises, B does not, C rises, and D does not. So I narrowed it down to 2 choices. Then I'm going to go back and say, okay, it's shifted to the left because of the pi over 10, and they both have shifted to the left. I can look and see that the asymptotes are the same, but just real quick, asymptotes are found normally at negative pi over 2 and pi over 2, but I've shifted to the left pi over 10. So I subtract pi over 10 and then simplify that to get my first asymptote and second one of a period. As I mentioned, they both have the same asymptotes. So the next thing I'm going to look for is halfway between the asymptotes. And halfway between here and here is closer to this value, not that value. And on C, halfway between is this. So that means that C is going to be our correct answer. All right, next I have y equals the cotangent. The cotangent, the period is pi, and it is undefined at multiples of pi. So it begins and ends at an asymptote. So I have an asymptote at 0, and I have an asymptote at pi. it still has halfway between my asymptotes is a 0, but halfway to the left this time it goes up, and halfway to the right it goes down. So that key feature, to summarize those key points, is that the cotangent falls as it goes from left to right. The tangent rises. And where it's undefined, you want to remember that those are your vertical asymptotes. So my vertical asymptotes are at 0 and its period, whereas in the tangent function, it straddled that y-axis. All right, so look at our examples. We have choose the correct graph of 2 periods of y equals 1/5 cotangent of 4x. So my cotangent graph falls. A is not falling, B and C are. So then I'm going to go look at my period. My period is pi over 4. So that's where my asymptotes are. They both have those asymptotes. So the next thing I'm going to look for is this 1/5 in front. And that's my A value, which means once I have my asymptotes and halfway between is a 0, that halfway to the left, I have to go up to 1/5. So I need to figure out if that's 1/5 or, well, this one doesn't cross at 0. So that means that B has to be our answer, because you can see 1 is way up here. So that is 1/5. All right, look at the next example. Y equals 4 times the cotangent of x plus pi over 4. Again, my cotangent falls. So A is rising, B is rising, C and D are both falling. Okay, that plus pi over 4 in the parentheses shifts it to the left. My period is pi. My asymptotes are 0 and pi, but I got shifted to the left pi over 4. So that gives me negative pi over 4 and 3/4, 3 pi over 4, which they both have. And I'm looking to see it halfway between. They both are crossing at 0. So then I'm looking at my A value in front, and that means halfway to the left it has to go up to 4. And this one does not go up to 4, so my answer is C. All right, next we have our cosecant. Our cosecant graph, the most important thing you want to remember about this, y'all, is what is the reciprocal of. And it is the reciprocal of the sine function. Because if you know the sine, you know the cosecant. Okay? The sine starts at a 0. So this dotted line is your sine curve. Starts at a 0, then it goes up to a max, 0, down to a max, and ends at a 0. And anywhere I have those zeros, I'm going to have asymptotes on my graphs. So my asymptotes, I didn't do a good job of drawing those, but y'all know what I mean. Okay. And then the other places, it has these parabolas, but notice that the vertex of each parabola is that value of the sine function, which in this case is A, or 1 for the parent function. Okay. So where it was zeros or where it's undefined, you've got to know those are your vertical asymptotes. Okay, so look at our examples. Choose the correct graph of 2 periods of y equals 9 times the cosecant of x. My cosecant, excuse me, is 1 over the sine, and that has a period of 2 pi, but it starts at 0. So which of these graphs starts at 0? A does not start at 0, B does not start at 0, C does, and D does. Okay, it starts at 0. That's where we have to have an asymptote. But my sine function has to go up. And C doesn't go up. And D does. And it's going to go up to that value of 9. And that's where my key points are. The vertices of each of my parabolas. Okay, look at this next one. Y equals 1/4 the cosecant of x over 3. Again, my cosecant is 1 over the sine, starts at 0 and has asymptotes at 0. So A has an asymptote at 0, B has an asymptote at 0, C does also. They all have asymptotes at 0, but I did notice, and I don't know if y'all picked up on this, is it's shifted. This is the midline on each of these, okay? And A and B have been shifted up and down, and there's no up and down in my graph. So that means there's no way for these two to be the answer, and it's C. And it does meet the criteria. 1/4 is the vertex of each of those parabolas, and my period, you can still see, is 2 pi over 1/3, which is 6 pi, which makes my asymptotes at 0, 6 pi, and 3 pi. Okay. Last curve we got to talk about is the secant curve. Again, what I think is important is for you to know that reciprocal. That reciprocal is 1 over the cosine. And here down below on the graph, cosine starts at a max, and then it goes to a 0 and a min and a 0 and a max. So these parabolas are going to straddle my y-axis, okay? And my asymptotes are on those odd multiples of pi. And that's what I just said here. That's where my function is undefined. So those things you've got to remember. All right, look at these examples. Last two examples. Graph two periods of the given secant function. Y equals 5 times the secant of x. You've got to know that's the reciprocal of the cosine. And the cosine starts at a max, has a period of 2 pi. So when it starts at a max, so where it starts at a max, y'all, that's the vertex of the parabola. So A is a possibility. B is not a possibility. C is not a possibility, but D is. So I have to find out between A and D. So now I'm going to go back to that number in front to find out what the vertex of my parabolas is, and in which case it's 5 and -5. And A is at 5 because this is not going to be 5. So my answer in this case is A. All right. Last example, choose the correct graph of two periods of y equals secant of x over 3. Again, secant is the cosine, which means it starts at a max. Starts at a max, and you got to remember that it straddles the y-axis. So A is not straddling B. Well, and if you look back, this is where it's starting. It's starting at 0. This one is starting at 0, so it's not possible. This one is starting at a min. So you didn't even have to know anything else. But if you want to check yourself, period is 2 pi over 1/3, which is 6 pi. Okay? That's all. These last slides, y'all, are giving you the information, the key graphs, sine, cosine, tangent rises as you go from left to right, cotangent falls as you go from left to right, cosecant, is 1 over the sine, and secant is 1 over the cosine. Thank you so much for watching, and y'all have a great day.